Okay, so first off, folks, let's take a look here. We have an equation, and it says solve using pencil and paper. Typically, that's the way we've been doing it for the most part on our iPads. Can I get somebody to help me out? What would be a logical first step for this particular question? What do you think, Luke? Awesome. Get your variable terms on one side and your numbers or your what we call constant terms to the other. Now, something that we did discuss yesterday a little bit. Remember, we've got a border here. Okay, so we've got Canada, we've got the US, and you can collect like terms as long as you're in the same country. Okay, so let's first make our lives a little easier by identifying some like terms on either side of the equation. So taking a look on the left side, are there any like terms? Do we see like terms there? What do you think? Sophia?
4m and the 5m.
Awesome. 4m and the 5m. So I'm going to take that, and I'm going to just highlight that real quick, just so that we know that those can go together. The number term, or the constant, is on its own. Okay? On the right side, obviously, there's only one term there. We don't need to worry about like terms. So what do we have on the left side if we collect those like terms? We want to make our life as simple as possible, so let's put anything together that we can. Jordan? Awesome. So we end up with that 3 stays as is and a plus 9m. On the right side, we're just going to keep that 21 as is. You'll notice, folks, that just 2 days ago, we started with an equation like this, where we had 2 terms on one side, 1 term on the other. So you'll notice bigger equations will eventually start to get smaller, and they will look a little more familiar. So now we're in a spot where we should know what we're doing. What do you guys think now? We want variables. It seems logical to keep variables on the left, constant terms on the right. What would be an ideal next step? What do you think? Anybody new? Oscar?
Get rid of the 3.
Awesome. Get rid of the 3 on the left side. We want to keep that variable term where he is. How could I do that, Oscar?
Negative 3. 100 to make 0.
Awesome. So we're going to essentially take it away so that that becomes 0. Whatever we do to one side, we're going to do to the other. What are we left with now, folks? What are we left with now that I've done a little bit of work here? What do you think, Adam?
18.
I've got 18 on the right side. What do I have on the left side, my friends? Megan?
9m.
Nicely done. And we're almost there. What is our last step? I know 9 m's are 18. How do I find out what 1m is? How about Anthony?
You just got to divide 18 by 9.
Nicely done. So remembering that's 9 times m, and we're going to do the opposite operation, which is divide. So 9 divided by 9, we have 1m left over, and m must equal 2. Remember, if we take this number 2, and we sub it back into the equation should work. So let's do that right now. Let's go with, how about, Andrew? Andrew C. What number is that?
2.
Awesome. When I go up to the equation up here, and I sub in m next to the 4, what's 4 times 2?
8.
Awesome. What's 5 times 2? 10. What is 10 plus 8?
18.
What is 18 plus 3?
21.
Does 21 equal 21?
Yes.
Then you're in good shape. So I know the equation works. Any other number I put here, if this is a 1, if this is a million, if this is negative 2, the equation's not going to work. There is only one answer that works. If I check my answer, there is no way that I can get any question wrong on the test if I understand what I'm doing, right? You can't make a mistake if you always go back and check, because then you know that you did something wrong and you can go back and address it, okay? So that, my friends, is essentially what we wanted you to accomplish yesterday.